Good morning, students. Our subject is Design of Concrete Structure 1. Our today's topic is a doubly reinforced rectangular section by limit state method part 2. In the last part 1, we solved one example to calculate moment of resistance. In today's lecture also, we are going to solve to find moment resistance. Okay. Example number 2. A beam 230 mm into 500 mm. Effective means beam having a width is 230 mm and effective means d is small d. Effective depth is 500 mm. Okay, is provided with 226 mm square. Steel on compression side means 226 is ASC, area of steel in compression side. Okay, cover to reinforced is 50 mm. Here cover is C is 50 mm. Okay. Assume 3 bar of 16 mm as a tensile reinforcement means 3 bar of 16 mm diameter is provided in a tension side. How to calculate AST, area of steel in tension side, is equals to number of bar into pi by 4 into d square. So number of bar is 3 into pi by 4, diameter is 16 square. So use M20 and Fe 500. The grade of concrete is M20 and the grade of steel is 500. Here we have to calculate Mu, moment resistance. Okay. Given data is B is 230 mm, FCK is 20 MPa, D is 500 mm, effective depth Fy is 500 MPa means grade of steel is 500, D dash means cover is 50 mm, area of steel in tension side is 3 number of bars pi by 4 into d square. So here AST is given, area of steel in tension side is 603.18 mm square. ASC is already given here, 226 mm square steel on compression side. So ASC is 226 mm square. Now first step we have to calculate here actual depth of neutral axis XU. Calculation of actual depth of neutral axis. So equilibrium requirement in a horizontal direction gives Cu plus Cu1 is equals to Tu. So what is Cu? Cu is 0.36 FCK into XU into B. So it is a Cu. So Cu1 is FSC minus FCC into ASC. It is a Cu1. And Tu is 0.87 Fy into AST. Okay, so we have to calculate here XU. So XU is equals to 0.87 into Fy into AST minus FSC minus FCC into ASC divided by 0.36 into FCK into B. So in this formula we have to put some values. So 0.87 Fy is given here, Fy is 500. So use this Fy 500. Fy is 500. AST we calculated here, AST is 603.18. So AST is 603.18 minus FSC. FSC value is given in one table. So here how to get FSC value for Fy 500? FSC value is 415. In part 1 I give you a one table here that for FSC value for grade 415 and grade of 500 is given here. How to get value of FSC? So here D dash divided by D. Our D dash is 50 mm cover and D is 500. So this ratio is 0.1. So for 500 grade and ratio is 0.1, for that our FSC is 412. Refer part 1 table. Okay, and FCC is 0, neglected. Why FCC is neglected? Because the ratio of 0.42 into D is smaller than 0.45 into Fy. So because of that we take FCC is equals to 0. It is neglected. Okay, so we put here FCC is FSC is 412 and FCC is 0. Okay, and ASC means area of steel in compression side is 226 divided by 0.36 into 20. 20 is FCK and 230 is here. B, our width is 230, so we put here 230, and solving these we get XU is 102.21 mm. Okay, now second step, calculation of critical depth of neutral axis means XU max. Second step, here we have to find XU max. So XU max is 0.46D. Why we take 0.46D? Also I give a one table in part 1 for XU max value. The grade of 500 mm steel grade, for that XU max value is 0.46D. So 0.46, and depth of beam is 500, so XU max is 230. Here XU is 102.21 and XU max is 230, so 230 is greater than XU, so our section is under reinforced section. Here in third step we compare XU and XU max. We know XU max is greater, XU max is 230 and XU is 102.21, so XU max is greater, so section is under reinforced section. How consider section is under reinforced, over reinforced, or balanced section? XU is equals to XU max, it is called as a balanced section. If XU is greater than XU max, then it is called as a over reinforced section, and XU is smaller than XU max, it is called as a under reinforced section. Okay, now we have to calculate here moment resistance mu. So mu is equals to Cu into Z plus Cu into Z dash. Okay, so mu is equals to Cu is 0.36 FCK into XU into B. It is a Cu value. And what is Z? Z means lever arm. Lever arm value is D minus 0.42 XU. Okay, plus Cu1 value is FSC minus FCC into ASC. It is a Cu1 value. Okay, and Z dash is D minus D dash. Now we have to put our values in this formula. So 0.36 FCK is 20, XU is 102.21, B is 230, width of beam is 230, D is 500 minus 0.42, XU is 102.21 plus FSC is 412. We already take for this XU to calculate XU max, we also used FSC and FCC value. So from this we take value, FSC is 412 and FCC is 0 into ASC is 226 is already given, into D is 500 and D dash is 50. D dash is also called as a C. Okay, so 50, and solving this we get mu. Mu is 119.26 kilonewton meter. Okay, or 119.26 into 10 to the power 6 Newton mm. So it is mu, moment resistance. Okay, so in this numerical we calculate XU, XU max, then compare XU and XU max, then decide section is between which category. After that we calculate moment resistance. Okay, now we take another example to calculate loading. So type 2 here, calculation of loading. calculation of loading means W. We have to find here load on W dash or W. Calculate loading on beam. Okay, so example number 3. A reinforced concrete simply supported beam of 8 meter span. 8 meter span means length of span is given here 8 meter with 300 mm into 500 mm effective cross section. Means B is 300 and D is effective depth is given. If mm effective cross section means effective depth is 500. Okay, is reinforced with 4 bar of 20 mm in tensile zone. Means AST is 4 bar of 20 mm. How to calculate AST? AST formula is number of bar into pi by 4 into d square. Number of bar is 4 into pi by 4. D is 20 square. So we get AST. Okay, and 4 bar of 16 mm on compression side means ASC. ASC is equals to number of bar into pi by 4 into d square. Number of bar is 4 into pi by 4 into diameter is 16 square. So we get ASC. Effective cover to both reinforcement means D dash and D is given here 50 mm. Okay, now determine moment of resistance means here we have to calculate mu and also calculate safe UDL excluding self weight of the beam. Means if we get self weight then minus from self weight of beam. Okay, so we got safe UDL can carry. Okay, so for that M20 and Fe415. So the grade of concrete is M20 and the grade of steel is Fe415. Okay, now given data, B width of beam is 300 mm, FCK is 20 MPa, Fy is 415, AST is given 4 bar of 20 mm diameter. So 4 bar pi by 4 into d diameter is 20 square. So AST is 1256.64 mm square. D effective depth of beam is 500 mm. Cover C is 50 mm and D dash is also 50 mm. ASC is 4 bar of 12 mm diameter. So 4 bar of pi by 4 into d square 16 square. So ASC is 804.25 mm square. So first step here to calculation of actual depth of neutral axis. Actual depth of neutral axis means XU. So XU is equals to formula to calculate XU is 0.87 Fy AST minus bracket FSC minus FCC into ASC divided by 0.36 FCK into B. Okay, so put a value in this formula. Our 0.87 into Fy is 415 is given here in given data. Fy is given here 415. Okay, AST we calculated here. AST is 1256.64. Okay, minus FSC, the value of FSC. How to get value of FSC? FSC value is taken from one table. For our grade of steel is 415 and our grade is 415. For that our ratio, take a ratio D dash divided by D. Our cover is here, cover is 50 divided by our depth is 500. So 50 divided by 500, our ratio is 0.1. So for 0.1 and ratio is 0.1 and our steel is 415. So for 415 take D dash, the value is it is FSC and FCC neglect here 0 because 0.45 into FCK is smaller than smaller than for 0.46 into D. So into ASC minus 0.36, FCK is 20 and B is here, B is 300. Okay, so we got here XU. Okay, so XU is we put here value 0.87, Fy is 415 AST is here 1256.64. FSC is for FE415, D dash divided by 50 divided by 500. The ratio is 0.1 for 0.1, and for FY415 the value of FSC is 352. So 352 minus FCC is 0. So ASC is 804.25 divided by 0.36. FCK is 20 into B is 300. So get here XU is 78.99 mm. We get here XU. Okay. Second, we have to calculate here calculation of critical depth of neutral axis. It is called as a XU max. So in second step, we have to calculate XU max. The formula for FE415. For FE415, the formula is 0.48 into D. Our D is 415. Sorry, our D is 500. So 0.46 into 500. XU max is our value. Okay. Compare XU and XU max. XU max is 240 and XU is 78.99. So our section is under reinforced section. Okay. Now calculation of moment of resistance MU. We have to calculate here calculation of moment resistance. So formula Cu into Z plus Cu1 into Z dash. Okay. So Mu is equals to 0.36 into FCK into XU into B into D minus 0.42 into XU plus FSC minus FCC into ASC into D minus D dash. Okay. So put value in this formula. Mu is equals to 0.36 into FCK is 20, XU is 78.99, B is 300, D into D is 500 minus 0.42, XU is 78.99 plus FSC is 353. Already we calculated here. Okay, FSC is 352 minus 0 into ASC is 804.25. Our into D depth is 500 and D dash cover is 50. So we get here Mu is 207.40 kilonewton meter. It is also we called equation number 1. Why we have to take two equations? Because in this numerical we have to calculate loading. Okay. So we have to calculate here loading W. So for that calculation of loading, we take Mu and factored Mu. So from this we get a W. Okay. So calculation of safe UDL, calculation of factored bending moment. So we take here moment. Moment is equals to WL square by 8. We don't know what is W, but we know what is L. Length is already given. 8 square divided by 8 into W. So BM maximum is 8 WU. Okay. So compare MU and MU B maximum. Compare these two. Okay. Or equating these two. So 8 WU is equals to our Mu is 207.40. So W is 207.40 divided by 8. So we got 25.93 kilonewton meter. It our W. Okay. So we have to find here safe UDL. Safe UDL is WU into FY. FY gamma F is 1.5. So 25.93 divided by gamma F 1.5. So W is 17.29 kilonewton meter. So our W is 17.29. Now we have to calculate here safe UDL. How to calculate safe UDL? Here in our example, we have to find excluding self weight. safe UDL but excluding self weight. So how to calculate excluding self weight? So W dash is W minus self weight of beam. Our W is here 17.29. Our self weight, how to calculate self weight of beam? Width of beam into overall depth of beam into per meter into density of concrete. So it 25, B is 0.3, means 0.3 meter, and depth is 550. Overall depth we have to take here capital D. So capital D is 0.55, because in example we having depth is 500 mm and cover is 50. So 50 plus 500, that is 550 mm, and 550 mm convert in meter, so it is 0.55. So the self weight safe UDL we have to calculate with excluding self weight. So the answer is 13.17 kilonewton meter. It is also called as superimposed load. Okay, now we take here another example. Find steel required. Here we have to design doubly reinforced beam. We don't know. In last 2-3 examples, AST is already given. In this example, we are going to calculate ASC and AST. Okay, so we take example number 4. A beam 200 into 200 mm, means square beam is given here, 200 mm into 200 mm. Effective means B is 200 and small d is 200 mm, because effective is given here. So carries a factored moment. Factored moment is 32 kilonewton meter at a section. So moment is given here. Factored moment is 32 kilonewton meter at a section. Find steel required. We have to calculate here ASC, AST. If concrete is M20 and the grade is Fe 500 are used. D dash cover is given 30 mm. Okay, so given data is B is 200 mm, small d is 200 mm, D dash cover is 30 mm, FCK is 20 Newton per mm square, Fy is 500, and Md is given here. Factored moment is 32 kilonewton meter, or 32 into 10 to the power 6 Newton mm. Okay, so Mu limiting. Here we don't know ASC, AST, so we can't calculate XU max because we don't know. ASC also we don't know. We have to calculate here ASC, AST in this example. So take Mu and Mu comparison. So Mu is 0.133 BD square FCK. Why we take this? For this formula is for Fe 500. Our the grade of steel is 500. So take 0.133 FCK BD square. If Fe 250 or Fe 415 is given, then another formula we already studied in part 1. So for Fe 500 the formula is 0.133 BD square into FCK. So 0.133, B is 200, D is also 200 square into FCK is 20. So our Mu limiting is 21.28 into 10 to the power 6 Newton mm, or 21.28 kilonewton meter. So Mu is given, Mu max, Mu limiting is also given. So here we have to calculate AST, ASC. So for concrete, grade is given M20 and the grade of steel is 500. So for that percentage is in IS 456-2000, for that percentage is given, percentage is 0.76. So how to calculate AST1? Use percentage 0.76 B into D. So percentage pt into b into d divided by 100 is our formula to calculate AST1. So PT is 0.76, B is 200 and D is 200 divided by 1000. So AST1 is 304 mm square. 304 mm square is our AST1. Now we have to balanced of factored movement. So we have to find here MD1. So MD1, how to calculate MD minus MU limiting? MD is 32 is already given. So MU limiting we calculated. So 21.28. 32 minus 21.28. So our MD factored moment is 10.72 kilonewton meter. Okay, by using AST1, MD1, we find ASC and total AST. Okay, so to find ASC, MD1 is equals to ASC minus into FSC minus FCC into D minus D dash. So FCC is 0.446 into 20. FCC is 8.92 Newton per mm square. So FCC our value is 8.92 Newton per mm square, and D dash divided by D, 30 divided by 200, our ratio is 0.12. So since steel is 500, our the grade of steel is 500, so for 500 and ratio is 0.15, our FSC is 395 Newton per mm square. So ASC, we don't know ASC, but we know MD is 10.72. So 10.72 into 10 to the power 6. ASC we don't know, but FSC we calculated 395. We know FCC 8.92 into D, depth of beam is 200 and D dash cover is 30. So go this transfer divided by here. So 10.72 divided by 10.72 into 10 to the power 6 divided by 395 minus 8.92 bracket close into 200 minus 30. So we got here ASC is 163.33 mm square. We get here AST1, ASC. Now we have to calculate total AST. Why we take AST1 and AST2 difference? Because sometime the bars, middle bar and corner bars, the diameter is different. Because of that we take AST and AST2 is different. Okay, so to find AST2, we know we already calculated AST1 and ASC also, so we have to find here AST2. By using ASC we easily find AST2. So ASC we find here 163.33 into FSC is 395. We already get here 395. FCC is 8.92 is equals to, we don't know ASC, AST2 into 0.87, Fy is 500. So AST2 is 144.96 mm square. We have to find here AST total. So addition of AST1 and AST2. So AST1 is 304 and AST2 is 144.96. So total AST is 448.96 mm square. Okay. So in today's lecture we solved 3 numerical example. In first we calculate MU, moment of resistance. How to calculate moment resistance? First step we find XU, then we find XU max, after that we compare it and then we find MU. In second example we find W. In these examples also we find XU, XU max, compare it, then MU and then find W. Okay, load. After that in third example we design doubly reinforced section. In this example there we have to find, we give to find AST and ASC. So in this numerical we find AST 1, then AST 2, and then total of AST 1 and AST 2, it is AST. Okay, anyone having question in today's lecture, you can put your question in chat box.